Alright, so for this first week, we're just going to kind of cover the basics of alternating current since we're moving on to AC from DC. Most of the electric power in the world is AC, so electricians work with AC about 99% of the time. The most common of all AC waveforms is going to be the sine wave because it is produced by a rotating machine. All rotating machines operate on the principle of the sine wave. The pistons of an internal combustion engine, for example, travel up and down inside the cylinder in a sine wave pattern because they are connected to a rotating crankshaft. AC voltage can be transformed and DC voltage cannot be. We're going to learn about the concepts of eddy currents and the skin effect that act as resistance to the flow of current in the AC circuit. We're also going to talk about the differences between peak, RMS, and average voltage values. Those are important concepts and they need to be understood. Some electric components such as capacitors and solid-state devices are very sensitive to voltage value, and that's why we're going to learn about the average voltage, peak, and RMS values. So starting off, one of the biggest advantages of AC is the fact that AC can be transformed and DC can't. A transformer permits voltage to be stepped up or stepped down. Voltage can be stepped up for the purpose of transmission and then stepped back down when it is to be used by a device. Unlike DC, AC reverses its direction of flow at periodic intervals, hence alternating current. Square waves are something we are going to encounter frequently. Each time the polarity reverses, the current flow through the circuit changes direction. So square waves can be produced by a simple single-pole double-throw switch connected to two batteries, but they're generally produced by electronic devices called oscillators, and that's what you're going to be doing this week. Another common AC wave, I know that's kind of fuzzy, waveform is the triangle wave. The triangle wave is a linear wave, one in which the voltage rises at a constant rate with respect to time. And the sine wave. We said the sine wave was the most common one. The sine wave is the most common of all AC waveforms. Sine waves are produced by all rotating machines. The sine wave contains a total of 360 electric degrees. So you're looking at 360 electric degrees when you're looking at a sine wave. It reaches its peak positive voltage at 90 degrees. It returns to a value of 0 voltage at 180, so that flat line, and then increases to its maximum negative voltage at 270 degrees and returns to 0 voltage at 360 degrees. So each complete waveform of 360 degrees is going to be called a cycle. So that's the first one right here. Let me go to iPad slide here. Each complete waveform of 360 degrees is called a cycle. We just said that. The number of complete cycles that occur in 1 second is called frequency. So you're going to hear that word thrown around a lot. Frequency is measured in hertz, and that's going to be Hz. Peak value, or also known as amplitude, is measured from 0 to the highest value obtained on either the positive or negative direction. The RMS value is the value indicated by almost all AC voltmeters and ammeters. Use an AC voltage that will produce the same amount of power as a like value of DC voltage. Average values of voltage and current are actually DC values. So going a little bit over wavelength. When current flows through a conductor, a magnetic field is created around that conductor. When high-frequency AC is used to produce a magnetic field, the field will radiate away from the source at the speed of light. Wavelength is the distance the radiating field or signal can travel during one cycle of alternating voltage. Resistive loads. So true power, aka watts, is the product of the volts times the amperes. And it can only be produced when both current and voltage are either positive or negative. Resistive loads are loads that contain pure resistance, such as electric heating equipment. So resistive loads are going to be defined by two certain things, and that is they produce heat and the current and voltage are in phase together. And the last thing we'll touch on is the skin effect. When current flows through a conductor connected to a source of DC, the electrons flow through the entire conductor. If that same conductor were connected to a source of AC, the resistance of that conductor to the flow of current would be slightly higher because of the skin effect. The AC induces eddy currents into the conductor. These eddy currents cause the electrons to be repelled toward the outer surface of the conductor. This is going to be called the skin effect. Your book goes a little bit more in depth about average values of voltage and RMS values, peak values, and there's going to be some questions that ask you to figure out those values. So read through your book, and it's going to go into better depth than this. Just remember that you're going to hear hertz a lot. You're going to hear about frequency. And the main thing to remember is in a sine wave, it's going at a 360 degree waveform, and that's going to be called a cycle for every complete cycle. So when it reaches its peak at 90, it goes down to 180 back to 0. Then it reaches its maximum negative voltage at 270 and back to 360, just a flat line. And that's the most important things for you to remember. And remember that resistive loads are defined by those two things. They produce heat, and the current and voltage are in phase together.